Hello everyone. In this video, we are going to present InstMove, instance motion for object-centric video segmentation. Video segmentation has attracted a lot of interest. However, cutting-edge methods still remain sensitive to occlusion and rapid movement. For example, the state-of-art method still fails to segment and track the occluded zebra and the dog accurately. One reason we observe is that most methods rely only on appearance to localize objects and track them across frames. To improve the ability of current methods in handling these complex scenarios, we propose InstMove, which relies on instance-level motion information, making it more robust to occlusion and fast-moving objects. With only a few lines of code, InstMove can be integrated into current state-of-art methods of 3 different video segmentation tasks and boost their performance. Now let's dive into details. In video segmentation, apart from the appearance cues, object motion, which is another crucial piece of information provided by videos, had been extensively studied. The majority of motion modules used in video segmentation and tracking fall into 2 categories. One lines of work use OptoFlow to compute the pixel-level motion. However, OptoFlow still heavily relies on the appearance cues to compute the pixel-level similarity across frames, making it less accurate in those scenarios. The other line of work uses a linear speed model to help alleviate those tracking problems. However, they oversimplify the problem and thus provide limited benefits for mask prediction. In this work, we aim at narrowing the gap between those 2 lines of work. We propose InstMove, which utilizes both pixel-level appearance cues and instance-level dynamic information to improve video segmentations and tracking tasks. Similar to OptoFlow, it also provides high-dimensional information on position and shape. Similar to the dynamic motion module, it lends physical interpretation to module motion information, thus improving robustness towards occlusion and fast motion. Specifically, we utilize an instance mask to indicate the position and shape of a target object, and provided an RNN-based module with a memory network to extract motion features from previous masks, and then predict the position and shape information of the next frame based on the motion cues. The training consists of 2 different steps. We first learn the memory network in the first step. We use an encoder cue to extract the motion features from the previous frames and the ground truth mask of the current frame. Then, the motion pattern Z is stored in a memory bank by a corresponding attention weight vector W. W is computed following this function. After that, we can retrieve the corresponding memory feature Z hat by a weighted sum of the memory vectors in the memory bank. After that, Z hat is combined with the output feature of the RNN module to get the final mask prediction. The parameters of the memory bank are updated by backpropagation. Note that in this step, the ground truth mask is also used as input. In the second step, given a fixed memory network, we can train another encoder P to extract motion features and retrieve the corresponding motion prior from the memory bank, following the same function in step 1. During inference, only the second step is used. We can also use the image feature at the very end of the mask decoder to obtain more accurate boundary estimates. Given the position and shape information of the next frame, we can use it to improve a series of video segmentation tasks for better tracking and segmentation. For video instance segmentation and multi-object tracking and segmentation tasks, we insert InstMove into the inference stage of existing methods to help them track multiple objects more effectively. Specifically, we input several frames that the module has already predicted and tracked into InstMove. It then generates a motion mask for the next frame. During the assignment process of the next frame, we calculate the mask IOU between the motion mask and the predicted mask of the module as part of the assignment score. For video object segmentation tasks, most methods performs object-level mask propagation and segmentation. Therefore, we use the motion mask predicted from the previous frames as prior information, and concatenate it with the feature map of the current frame. Then we input it into the VOS module to enhance the segmentation quality. By adding a few lines of code, we can easily insert InstMove into most of the video tracking and segmentation modules and improve their performance. First, we validate the effectiveness of InstMove on three popular online video instant segmentation algorithms. We consider OVIS dataset, OVIS sparse dataset, and YouTube-based long dataset. OVIS dataset features severe occlusions, and OVIS sparse dataset and YouTube-based long dataset are subsets of OVIS and YouTube-based with a low frame sampling rate, leading to more fast-moving objects. By adding InstMove into three different state-of-art methods, we improve their performance on all benchmarks by a large margin. In addition, we test the improvement of InstMove on multi-object tracking and segmentation algorithms using the BDD100K dataset. Notice that for this task, we only use motion prediction to improve the tracking accuracy. We observe a reduction in ID switch occurrence. To further demonstrate its effectiveness on occluded objects, we divided the validation set into a occlusion subset and a continuous subset based on whether the object disappear and reappear. For the occlusion subset, the average ID switch occurrence significantly decreased from 130% to 96%. We also conduct experiment on the video object segmentation task and observe improvement on both two benchmarks. These slides provide more visualization results. We can see that with the help of our motion prediction plugin, the previous state-of-art methods becomes more robust to occlusion and fast-moving objects. We also provide video results here. To sum up, we propose InstMove, which is a very simple motion prediction plugin with a memory network, but it can significantly improve all video segmentation methods. That's all for the presentation. Thank you.